Section 1.5 is on angle relationships. And in this section, we're going to define a whole bunch of different relationships between pairs of angles. So, the first definition is for adjacent angles. Adjacent angles share a common vertex and a common side. In other words, they're two angles that are right next to each other. They're going to have the same vertex, and they're going to share a ray. So, for example, in this diagram, angle 1 and angle 2 are a pair of adjacent angles. Angle 2 and angle 3 are another pair of adjacent angles. But angles 1 and 3 are not adjacent, although they share a vertex. They do not share a common side. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So in this diagram here, angles 1 and 2 are adjacent angles, and they're non-common sides. So in other words, the side that they don't share. Angles 1 and 2 both share ray BD, but they do not share ray BA and ray BC. And those are opposite rays because they form a straight line. Basically, a linear pair is a pair of adjacent angles that when you put them next to each other, they make a straight line. Vertical angles are two non-adjacent angles that are formed by intersecting lines. So here we have two lines that intersect each other, and the vertical angles are the ones that are across from each other. They're not adjacent to each other. They share a vertex, but they don't share any common sides. So angles 1 and 2 are a pair of vertical angles, and angles 3 and 4 are another pair of vertical angles. And here's your first theorem. Vertical angles are congruent. So angle 1 is going to be congruent to angle 2, and angle 3 is going to be congruent to angle 4. Complementary angles are two angles whose measures add up to 90, and they do not need to be adjacent. So look at this first diagram here. The large angle here is a right angle, and I know that because of this little box in the corner. And angles 1 and 2 are make up that right angle. So angles 1 and 2 are a pair of complementary angles. And also over here, angle A measures 30 degrees, angle B measures 60 degrees, and 30 plus 60 is 90. So angles A and B are also another pair of complementary angles. They don't have to share a common side. They do not have to be adjacent. They just need to add up to 90. Supplementary angles are two angles whose measures add up to 180. And again, as with complementary angles, these do not have to be adjacent. And angles that form a linear pair are supplementary. So in the first diagram here, we have angles 3 and 4, and they add up to 180 because the two of them next to each other make a straight line. You'll also notice that angles 3 and 4 form a linear pair. Angles C and D, measure of angle C is 120, the measure of angle D is 60, 120 plus 60 is 180, so that's another pair of supplementary angles because the measure of angle C plus the measure of angle D equals 180. However, angles C and D do not form a linear pair because they're not right next to each other and they don't share a common side. So here's an example. Angles A and B are supplementary. If the measure of angle A is 6 less than 5 times the measure of angle B, then find the measure of each angle. So I know that the two angles are supplementary, so I know they're going to add up to 180. And then reading the problem, it says, so it basically defines the measure of angle A in terms of the measure of angle B. So I'm going to define my variables. I'm going to say let x equal the measure of angle B. Okay, then if x is angle B, then the measure of angle A, and reading directly from the problem, is 6 less than 5 times B. So 6 less than 5 times B, and I defined angle B to be x. So measure of angle A plus the measure of angle B equals 180, because the problem told me they are supplementary. So now I can just plug in my algebraic expressions. A is 5x minus 6, measure of angle B is x, and that equals 180. So 6x equals 186, or x equals 31. And I'm not done. If I were in algebra, I'd probably be finished once I find x. But this problem says find the measure of each angle. So the measure of angle A was 5 times x minus 6, or 149. And the measure of angle B was equal to x, which is 31. So angle A is 149, B is 31. You can do a quick check. Do those add up to 180? Indeed they do. Our next definition is of the word perpendicular. Perpendicular means that it forms a right angle. And the symbol we use for that is this little upside down T, and actually it's a line with another vertical line that looks perpendicular to it. So looking at this diagram, line AC is perpendicular to line BD because they form a right angle. And we designate that with a little box in the corner here. A couple things that kind of flow from that definition. Perpendicular lines always form right angles, and perpendicular lines form congruent adjacent angles. Think about it. Any two angles that are next to each other, any two adjacent angles, are going to be congruent, which kind of makes sense because they're all right angles. And here's an example. This says find x and y so that line AC is perpendicular to line BD. They're not telling us that AC is perpendicular to BD, but depending on whatever the value of x and y are, we can make those lines be perpendicular. So if they are indeed perpendicular, they're going to have to add up to 90 degrees. Any of those angles are going to have to be 90 degrees. So looking at the diagram here, I have this angle right here. I don't have a name for my vertex. Maybe I'll go ahead and name that, give that point F. So angle AFE is 3x plus 6, and angle EFD is 9x. So in order for those lines to be perpendicular, those two angles need to add up to 90 degrees. So 3x plus 6 plus 9x has to equal 90 degrees. Or 12x equals 84. So x has to equal 7. And in this case, I can box x because notice the problem says find x and y. Now, over here we have angle BFC, and in order for AC to be perpendicular to BD, this angle also needs to measure 90 degrees. So 3y plus 6 equals 90, or 3y equals 84, or y equals 28. So it's not given that AC is perpendicular to BD, but if x equals 7 and y equals 28, then those two lines are indeed perpendicular to each other. And the last thing we're going to take a look at is this little chart right out of your textbook called Interpreting Diagrams. One thing in geometry is it's easy to look at a picture and make certain assumptions. So I could look at this picture and say, oh, it sure looks like angle JHL is a right angle because it looks pretty close to 90 degrees. But you cannot assume that because there's not a little box in here. I could also say it looks like segment HJ is the same length or congruent to segment HK. But I can't say that because it's not marked with those little pink slash marks. So here's a list of things, and I'm not going to go through all of them, that you can assume from this picture. Okay, all of the points are coplanar, certain angles are adjacent, or form a linear pair, or supplementary. And here's a list of things you cannot assume. Pretty much a lot of this has to do with congruency, you'll notice, and perpendicularness. Okay, you can't assume that two things are congruent or that two lines are perpendicular unless it is marked in the diagram. So in this section we learned about a whole lot of different types of angles. Make sure you memorize those and are familiar with all of them.